We are starting with our first session today. It's Auditing in Cloud Computing Solutions with OpenStack. We have Divya Kunur from IBM who will be presenting this. Over to you, Divya.
Can you hear me? Can you hear me? Yeah, okay, great. Good morning and thanks for coming. Before I start the session, I just want to know how many of you have heard of OpenStack. Raise your hand. Okay, how many are working in OpenStack? Okay. Okay, and how many have heard of virtualization or is working on virtualization? Okay, great. Okay, I think let's get started then. So this is what I have for today. Well, I will spend a little bit of time on OpenStack because I think the population here seems to be a little new there. So, sorry. Okay. So before I start, I just want to say a small story so that we all are on the same plane, so as to speak. So this story starts many years back, like 10 years back. So this is, I felt that before I talk about OpenStack, it's very important to kind of tell what led to OpenStack. So this was a time many years back when, let's say, a bank or a travel company, they wanted to run their core application. And what they would do is they would go to a server company or a storage company and say that, hey, I have this critical application, give me a server. And the server company would give a big, expensive physical box, which the bank or the travel company would go, take, run the application. Now, what's the problem with this model? The obvious problem is that you have a big physical expensive block, resource, which has a lot of resources in it, and you are running one small application in it. So, and that's extremely expensive. So then, while all these banks and other companies were dealing with this problem, the server company came back and said, hey, we've come up with this new technology, it's called virtualization. And now instead of having one big server where you run this one small critical application, you can break up your physical server into smaller pieces, which are called your virtual servers. So now what happens is that the company, the bank or the travel agency, whoever that might be, they can break it up into different units and they can run their different application on top of it. So which means that the total number of the resources that are utilized is much higher than before. Now over a period of time, the bank grew, they bought more servers, more storage, and now they have a big data center. So now what happens if you have many servers, many storage, you have to maintain a data center? Okay, great. You can now break up your big piece into smaller servers, smaller storage units, that's volumes or LUNs or whatever it might be. But then the company, the bank, the core expertise of the bank is banking, but they still have to spend a lot of money maintaining these servers. So when I say maintaining these servers, it's, it could involve everything from physically securing the server, ensure that there is enough cooling for your servers, firmware updates, security patches, whatnot, OS upgrade. So there are a variety of things that you have to take care of. So instead of actually taking care of your banking stuff, you're now taking care of a lot of other things. And that's when the cloud folks came in. So the cloud folks came in and they said that, hey, you don't want to do all these things? No problem, we're going to do it for you. So what does the cloud do? What they do is they basically say that, okay, you don't have to actually maintain all these servers. We will do it for you. And another problem that the banking or the different customers were facing is that during the peak season, they would need a lot of resources. And off-peak season, they don't need all those resources. So which means that even during off-peak season, they have to actually manage all those resources, all those servers they have, which was just an overhead. So the cloud folks came in and said that, okay, it's okay. You want 5 servers during your peak season? We'll give you 5 servers, you just have to pay for those 5 things. You need only 1 for off-peak, we'll do that. So all you have to do is, you just have to pay for what you use. And that was a very cool model because then companies did not have to spend all that money, take care of all that maintenance which they had to take care of earlier. So if you're already from a cloud space, you know that there are different models of cloud, the public cloud, which is your Amazon, so soft layers, and your private cloud, which you can set up in your private environment. When I remember the time 7 years back when, so I work in IBM. 7 years back, even for testing and development, we used to have to wait for our virtualized server to be available and check if someone else is using that virtual server, and then send a mail, and the monitor is not working. And send a mail and say that, hey, are you done with this? When can you give me this? And stuff like that. And now we have a private cloud which is set up, wherein all we have to do is we just log into a portal and say that, okay, I want a RHEL 7.1 OS. I want it from this time to this time, and within 5 minutes it's ready. So I just have to use it and throw it on a need basis. So that's where cloud has come in. Now, with the emergence of cloud, what has come in is the need for cloud software. And that's where a lot of players, in fact, I think most of the people listed here, most of the companies, I think everyone has a cloud solution. I even remember buying a D-Link network camera 4 years back from D-Link, which is a general network camera to monitor your home. And it was sold as network camera. But last year when I bought it, the same model, they named it a cloud camera. So everything has cloud now. So with this, what has come in is, all the companies, they are entering into this cloud space, and they're coming up with their own cloud softwares. Now, what is the problem with every company coming up with their own cloud software? Basically, all of them are trying to do the same thing at a functional basic level, but all of them want to have their value add. So every company will have their own something unique which they want to add, but they still have to go through that 6-month or 1-year period to write their code or write their software from scratch, and then bring it to a point where the basic functionality work. And it's only after that they get to spend another 2 years to put their value add. So which means that 6 months to 1 year, or many a time even more, all the time is lost. And that's when all these major players, so you can see all these people, which is the same as these people here. So they all came together and they thought that this is stupidity, foolishness, let's all come together and let's all work on a common platform. Anyway, all of us need the same thing, and then once the common platform is available, let's start building on top of it. So that's where OpenStack comes in. And OpenStack is the most popular open source cloud platform that we have now, with all the major players using this as a base. So what is OpenStack, and how is it kind of different from others from an architectural perspective? So one thing is, earlier what we used to do, one thing is, of course, it's open source. There are all these big players contributing to it. And the second thing is, from an architectural perspective, it has taken care, it has been very cautious with the way in which it has taken the lessons from different architectural problems and tried to solve all that problem. But this session is not about OpenStack, so I'll move on. But one thing is that, as you see in the diagram here, it tries to bring together your compute network and storage resources to enable cloud. So moving on to the next slide. Oh. Okay. This is OpenStack. So if you do a Google search looking for OpenStack architecture, this is what you get. And then you might think it's a mistake, and you might do the Google search again, and you'll still get different images for different releases, which looks like this. It's very difficult to understand. The first time I saw this, I thought that it's too scary, and I don't think anybody would ever be able to learn OpenStack. But then if you look a little closely, what it has is, earlier I remember that when, before cloud came into picture, we used to work on the space called system management space, or before OpenStack. So if there are 3 features that we need, say A, B, and C, we used to develop A, B, and C, put it into one application, and over a period of time, it would be too tightly coupled. And then after 5 years or 3 years, you figure out that nobody is actually using C, and maybe we should try to remove C. But then C is so tightly integrated with the product, there's no way you can remove C, no matter how hard you try. And then I'm sure there'll be some POCs going somewhere, or internship projects going on somewhere trying to remove that, which will never happen. So the thing about OpenStack is a group of services where each service is independent of each other and they come together just like this conference where different people from, all of us from different companies come together and try to make something happen. So what you see here are actually different services. So here what you see is called the NOAA service, which is your compute service. And the thing about OpenStack services is that if you don't want two services, you don't want, so when I say different services, you have NOAA, which is your compute service, Cinder, your storage service, Glance, image service, and so on. So for some reason you don't want a particular service, you can just let go of it and live with the others. So for example, folks who are working in storage, they might probably just need Cinder and Keystone to set up their storage specific stuff, or Swift and Keystone, and they don't have to install the other thing. But as such, if you want to get started with OpenStack, it's all in the community. You just download OpenStack code, run a script, and it gets installed. So it's as simple as that. But one thing I want to mention about OpenStack architecture, which is very important to explain the rest of or to understand the rest of the stuff, is that the OpenStack architecture, by virtue of every service being independent, every service, it is exposed. Every functionality in every service is exposed via REST API. So which means that if you want to access anything within a service, you have to invoke REST API. So moving on to next one. Yeah. So we are closer to our original topic here. So what's auditing? So I was talking about cloud, and one of the biggest concerns all these big players like banks and others, they don't want to move into cloud, is because of security. So there are a variety of security concerns which I don't want to get into, but how does auditing solve those concerns? So trust is one of the problems. So if I'm a bank and I use public cloud, I would want to know what is happening on my resources, who's doing what. And if I go and ask my cloud provider, hey, what's happening? I think something went, someone deleted my virtual machine at this particular time. Can you go and check? Can you tell me who did that? And if there is no audit trail, there is no way the cloud provider can give you that detail. So if the cloud provider says that, hey, we have audit enabled for our cloud solution, what happens is the customer has better trust to start using cloud. So auditing, this definition I took from Wikipedia, it just says that basically any operation that has happened in your environment. Now, auditing is, you have physical auditing, and as such, it's not a new concept. It has to be there in every application that you sell. But in a cloud, it becomes all the more important, especially because we are dealing with other customers, which are referred to as tenants. So it is a very critical part of a cloud. So moving on to the next one. This is about cloud audit standard. So now let's say that there are 2 or 3 different cloud providers, and they say, and I'm a bank, and I go to the different cloud providers and I ask, okay, do you have auditing? And they say, yes, we have auditing, and each one has a different way to audit, which means that the first one would be storing just some information for the sake of storing, and the other folks might be storing in a different way. But there's no mechanism wherein mechanism or body to ensure that, yes, they are storing the required information. Because at some point of time when it's actually required, that might be the time you figure out that they don't have the data that we need to figure out what went wrong in the system or what happened in the system. So that's where a lot of players, they made a work group, and there were players from EMC, Huawei, IBM, all got together and thought that it was very important to come up with this audit standard, and they came up with something called CADF, which is Cloud Auditing Data Federation Group. And yeah, I think it's very small, but I'll just explain what it is. So what the standard mandates is that if you have a cloud application, and if you say you're CADF, first thing is you're supposed to be CADF compliant. If you say you're CADF compliant, your audit record should have all this information. So first thing is, any operation that happens in your environment should have an audit record associated with it. And the second thing is the audit record should have all this information. So it's called the 7 Ws of CADF. So it basically says, first thing is, what was the action? So for example, someone deleted a virtual machine, or someone created a volume. That's an action. When did that happen? Of course, the time when it happened. Who initiated it? Who is generally the specific user who has initiated it? On what was initiated? So for example, what was the exact virtual machine or volume that was deleted, that was created, and so on. Where from to, all that it talks about, where as in was it invoked from a command line, what was the state before the initiation and after it was initiated. That is, you gave a request or did an operation to start it, was it successful, not successful, and so on. So basically, when you say you're CADF compliant, all this information should be there, and all this information is required to say that, you know, what exactly happened at that particular time in your environment. Okay. So next is PyCADF. So now the next few slides talk about how OpenStack has used this standard and how it is implemented. So I think till now whatever I explained, it might make sense to you. The next few things might not make sense, but please bear with me. So PyCADF is basically an open source library, and it's written in Python. OpenStack is written in Python, I think there might be other people who might be trying to write it in Java as well. But then what it does is, it is basically a Python implementation of CADF, which means that it provides APIs which you can invoke, and it generates an event. And the event, so you can pass in the values, that is the 7 Ws which we just spoke about, and it will generate an event in a JSON format. So effectively that's what it does. And this is used in OpenStack for audit data generation. So this was introduced in Havana release. So the current release OpenStack is Liberty, and before that there was Kilo, and before that there was Icehouse, and before that Havana. So this was released sometime in Havana. Yeah, sure. So first thing is, PyCADF is a Python library. So any product can use it. It doesn't have to be OpenStack based. Second thing is, if you're already using OpenStack, it just can be plugged in. It's already in place. You just have to make configuration changes to use it. So now we come to how it works. So for this, I have to go back to what I just spoke about, which is OpenStack is nothing but bunch of services. So let me take a minute to talk about logging. So how do we enable logging in our application? We write code, and we have this log.level warning, hello, hi, how are you? And then it comes to the log file and it gets generated. So for that, you have to go to the to the specific code you're writing, and you have to add a line so that when it runs, it generates that message. So as you know, OpenStack, it has already many services in place, and every other release there are new services coming in. So if the audit mechanism has to be integrated into OpenStack, and if somebody had to go and in each file or piece of code had to do something like import PyCADF and call that particular API to generate the event, that would have been, people would say, no, we cannot do it. That's too much of effort, because for every code you'll have to do it, and that would be too much. So yeah, sure. No, I'll come to that. So that's exactly what I'm explaining. So in the case of OpenStack, which uses Python, there is something called the pipeline and paste element, but it could work differently in other models as well. So the way it works is, now if this is an OpenStack service, any REST call that comes, it comes through something called a pipeline of filters. It's also called middleware. So if this is your actual, say, Nova service, which is a compute service, when somebody places a REST call, it has to first go through a filter which does authentication. That is, whoever is using the credential, it's a valid credential or not. Another middleware would be something which creates something called a context object, which populates all your context, your user, other information. So similarly, the way in which audit has been integrated is via a middleware. So which means that the PyCADF library has been written in such a way that it can be used as a middleware, and you can just plug it into your pipeline so that any REST call that is made to the service, just like it hits the other authentication middleware and so on, it hits the audit middleware as such, so that what happens is for every REST call, there is an audit event that is generated. So this is drastically different from the earlier model where each line of code you have to go and call the API and write it. It's very simple because then for any service you can just plug it. If you don't want auditing, you just have to remove it. So I'll show you how it is. Okay, yeah. So this is the configuration file of a Nova service. So what you see there is the audit middleware. And if you see up, it just talks about configuration. Might sound, look a little complicated, but I just want to ensure that, say that what happens is when anybody makes a compute service call, which means that I want to deploy a virtual machine, so that's a REST API call. It comes through, it passes through all these filters. It's also called middleware. And the last one that you see here, this is the actual Nova service application which processes your request. So what you see here, for example, the auth token is the authentication one, which I was just talking about, where it checks if your token or your credentials are valid. The next one, keystone context, creates a Nova context object and populates information. So if you don't want the auditing for Nova service, you just have to remove this and restart your service, and there won't be any auditing. But if you want auditing to be enabled, you just add it. And the audit middleware configuration is added here. So as you see here, you see that it refers to the PyCADF API. So what happens is the REST call comes, it hits the audit filter, and it goes here, and it goes and generates an event. The other things I'll just explain in a minute. One thing I want to just mention is the ignore request list. So in a cloud environment, we are talking about, when we talk about auditing, we are talking about auditing or generating an audit event for every single operation that is happening. And you can imagine how many operations would happen in a single minute, which means we're talking about humongous amount of data. And when we say that for every REST API it happens, REST API can be of, it's basically HTTPS calls. It can be a create call, delete call, post, put, whatever it is. So a cloud provider might feel that it's a lot of data and I want to do some kind of filtering. I don't want read operations to be audited at all, because anyway there's no security risk associated with it. People are just coming and reading it. They cannot make any change. So I don't want get operation, that is read operation, to be audited. So all you have to do is you have to add that as part of your ignore list here. You can add whatever you want, and you can ignore the operations which you don't want to be audited. The next one I will talk about is the audit map file. Yeah, sure.
Configuration that we have to do?
Exactly, exactly. That's the beauty of this particular middleware, that you don't have to make any changes in your code. And if you come up with a new service tomorrow, you just have to make the changes which I just spoke about, and few other things. So PyCADF is, like I said, it's an open source library. It's available in GitHub, just like other OpenStack stuff, code. So what is required is for each service, there needs to be a map, which is called the audit map, which needs to be present. So as you see right now in the community, there are audit maps present for six of the services. So what exactly is the audit map doing? The audit map, okay. So the audit map basically has all the REST APIs that are supported by that particular service, so that it's basically saying that these are the REST APIs and you have to audit these REST APIs, which means that tomorrow a particular service plans to add or comes up with new REST APIs that needs to be updated here. Or if a cloud provider feels that there are some REST APIs which are actually not required to be audited, you can just remove it from here. But if you're coming up with a totally new OpenStack service, you have to go to PyCADF and add an audit file. And if you don't have audit file, your auditing will not happen at all. Okay. So, so the last portion, we have come to the last portion of this presentation. So what happens to all the audit data? So now you have lots and lots of audit data. So to answer one of the questions that was asked here, where does all the audit data go to? Does it go to the logs? Then how do you make sense of the audit data in the log? So There are two ways in which you can configure an OpenStack. One is you can say that I want all the audit data to go to logs. But then what happens then is that there are a huge amount of audit data in the CAD format which goes to the logs. It is not actually structured. You need a tool to first make sense out of it, make it organized, and then it's a non-recommended old way of doing it, just putting it into the logs. Of course, it can be protected by file permission, but you cannot run query and enable more RBAC, that is role-based access control. You cannot define which other roles or which other set of users who can access it, so that flexibility will not be there. So what OpenStack has done is, OpenStack has a service called Ceilometer service. How many of you have heard of Ceilometer service? Okay, so what Ceilometer service does, it's basically the telemetry service of OpenStack. It stores the metrics and event information from other services. So for example, an example of metric is you have 10 virtual machines deployed in your cloud environment. The CPU utilization, memory, disk usage, there are metrics associated with virtual machines. And this is not stored in Nova. It's actually sent, and it's a Ceilometer service database which collects all this information and stores it. The events are, so for example, somebody critical data, and we don't want anybody to be just using it. So this talks about the configuration. Yeah, sure. Okay. So I'll come to the other services in a minute. Okay, so this is a little more low-level detail, but on the right-hand side, what you see is, so each service, it can send its audit data to something called a control exchange. So for example, for Nova, you can set up a control exchange called Nova and send it to that one. And Ceilometer can be configured to read it from each of those control exchange and finally store it in their database. So this is the last slide. This again kind of lists the entire flow here, so I'll just explain it end to end. So first you have different services. You have to set up your audit middleware with it, which is very simple. You don't have to change the code. Anybody who places a REST call, the audit record is generated, and the audit record, based on the configuration, it can either be sent to the log file or you can send it to the message queue. And from the message queue, the Ceilometer service takes it and stores it. So that's a good story, but the question is, it goes to the Ceilometer database. Next what? Do you just run a query? You can run a Ceilometer query, and it will give you 1,000 audit data, which is in JSON format. And what do you do with it? How do you make sense of it? And that's where you need a security intelligence tool. So the advantage of the format or the standard being CADF is that you can, so there are different security intelligence tools available. So IBM has something called QRadar, which is CADF compliant. So it basically means that it has the ability to read audit events which are of this particular format, and it can make sense out of it. So which means that when I say other services, you can integrate a security intelligence tool into your system. So if you have multiple clouds or even multiple cloud providers, so if I'm a banking customer, I have my resources in different places, I can set up one security intelligence tool or a data analytics tool and monitor my audit data live. So in fact, there was a demo that was given in OpenStack Summit around the same lines, wherein there was, so the scenario is a rogue admin. He's just been given a, he's just quitting the company, and he thinks that, okay, I'll go and mess up with this cloud and data center, and then he goes and starts deleting the VM. So in the data security intelligence tool, you can set up patterns which says that if there is some activity of this kind, send a high alert. So as soon as somebody tries to hit the REST API, even before it hits the actual application, there is an audit record that's generated. So the security intelligence tool can continuously take this, monitor it, and give live information of what is happening in your environment and how you can stop it. So that's what it can be used for. So I think that's all I had. All the references or things I used is here. The whole thing about auditing being used in cloud and in OpenStack is a very new concept, and I think companies are still just starting to adopt it. And like I said, it has been contributed just last year into the community. So. The PyCADF library as such can be used by anyone, but if you're already using OpenStack, it's very easy to integrate it, even if you have a new service coming in. So that's all I had for today. I hope you enjoyed the session. Thanks very much. Questions?
No, I just want to know that whether you would be doing best practices or should I just pick?
I think she will have to answer that.
So I like to see the references which you have mentioned to the on the slides. Yeah, are these slides available or will I get these restrictions?
She basically wants the reference links here. So she wants to know if the slide will be made available. It's all available in Google online.
So I know clicking photographs as well. I don't know if it's allowed. Okay.
As long as you pay me. Yeah, there's a question there.
What kind of telemetry data you will be collecting to secure your data, basically, the information which is there?
Yeah, so are you already familiar with the telemetry service?
I am not familiar with the current telemetry, but we also have some telemetry. So I want to know more detail of the telemetry data which you are having and the security around that.
Okay, so what happens is when all the services they generate this audit event, it's basically a message that goes into the queue, and the message needs to have something called the event type associated. So the event type for all CADF compliant audit records in OpenStack, it is of this format: audit.http.request and http.response. So each of the servers, they generate this message, it has this event type, and then it is sent to the queue. And Cerometer, which is a telemetry service, it has listeners to listen to different control exchange into the message queue. So it goes and collects it, and it processes it a little, and it puts it into the database under this particular event type. So which means that now you have all the data into your Celometer database. Now because we are dealing with a lot of data here, unlike the other kind of events, Celometer, it can be configured with a NoSQL database as well, and MongoDB is the most sought after option. So Celometer, it has different APIs. So currently this particular audit event, it is stored as something called event. Till Icehouse release, that is 2 releases back, all this thing was saved as something called meters. Now it has been deprecated, and now it is stored as events. So which means that if you want to get the audit data information, what you do is you invoke the Celometer REST API, which says that get me all events with a query parameter which says that the event type is audit.http.request, and it gives you the event information. Now what RBAC, there is role-based access control in place which can be used to define who can place that REST API. So there is a configuration file in OpenStack for every service. It's called the policy JSON, where you can say that if this is the REST API, this is the kind of user who can access it. So as such in OpenStack, there is something called the role concept, so you can define your own roles. You can say admin, deployer, and so on. So you can say that only the admin, any user with the admin role can access it. So if you're not of admin role, right now the way in which it works in Celometer is, if you're not an admin role, you get to see the events which were generated by you. But if you are of admin, you can see all events.
Hacked credentials, so there's no authentication. Again, one more layer for the authentication.
So in OpenStack, by default, all REST calls go via a layer of authentication. So I'll explain, sorry. Okay, so this is the one. So in OpenStack, by default, whenever a REST API is placed, first first the REST call goes through a layer called auth token. So auth token is the authentication layer here. So what it does is it basically makes a call to your identity API. So in Keystone context, it's called, in OpenStack context, it's called Keystone. So what the Keystone service does is it takes your credential and it checks if the credentials are actually valid, and all kind of authentication and authorization things are checked, and only after that it even reaches the audit layer. So which means that if you have to access your audit data, which is in Silometer database, you have to make a REST call, and first the REST call goes through the layer of authentication, and only if the authentication is clear, it will go through.
Or it's a static token what is given to every client?
So the way auth token is generated is, so first thing is auth token is generated using the Keystone service, which is a separate service in OpenStack. So for that, you can take any valid credential. So there are different ways in which you can configure it. So you can configure Keystone to use LDAP directory, or you can configure it to use the data from your database, which is Keystone database, or you can even configure it to use the OS registry. So which means that, for example, if you configure it using the OS registry, when you make authentication call, so you give Divya, it goes and checks if there is an OS user named Divya and the credential is Divya, and then it does the authentication. And after the authentication is done, it generates a token. And the token is generated such that it has information about the user and the project and role and other things that are associated with the user. So when you make a REST call here, when it comes to the auth token layer, it's not just the credentials that are validated. It's also checking what project and what role and other things that you have. Anybody?
Yeah. So I have two questions.
Yeah.
The one basic question is, is the audit trail generated only for REST APIs, or mine is a proprietary software, say I have placed it on cloud, and I want to use this audit trail. So only the REST APIs which are exposed in my applications will be audit trail enabled, or generally everything?
That's actually quite a good question, because many people have asked if you're using a command line and then the command line is invoking the REST API, your auditing happens only after you invoke the REST API. So all the things that have happened in your command line, what happens to that?
Correct.
So right now in OpenStack, that facility is not there. And like I said, this is kind of recent thing. Auditing is recent, because first you think about functionality, then you think about security. That's how applications are developed. And but if you come up with a mechanism to do that, you can just go and contribute it, and that's the beauty of the whole thing. But that's a good question. It's not there. That support is not there.
The second question is on the metrics. Say on the VM, if I want the real-time data as to, we already have it in SAR and other things, right? So here with the audit trail, how do I capture, or how do I get those metrics?
So first thing is, there are two things here. One is the metrics and one is the audit trail.
Correct.
So both should not be confused with each other. So the only thing common between, or the primary thing common between both of them is that both of them are residing in the Silometer database. So Silometer is just a service which has been used to capture both the information and store it in the same database. But functionality wise, if you see, auditing is intended for a separate purpose and metrics is intended for a separate purpose. So both cannot be clubbed, but it's another thing that in Silometer till last few releases, the metric concept was used to store the audit data, but functionally, conceptually, they're different things.
All right. Thank you, Divya.
Yes, so I don't have the performance metrics here, but in general, if you have a middleware in between, it's definitely going to affect your performance, because it is going through the flow where every REST API, for every kind of HTTP request, it's going through the flow of generating an event, and that's going to the messaging queue, and then your Silometer is reading it. And the other problem that generally customers would run into is your Silometer database growing and growing. So after you've installed in a production environment OpenStack, if you have auditing enabled, your Ceilometer database is going to become so huge that it's going to eat up all your space, and then you will see that all your other services have stopped running, and then when you figure out it's a Ceilometer database. But Ceilometer also has a provision called event purging, wherein you can say that every 1 week I want this information to be purged, but you don't still want to do that for auditing because that's critical data. But this is a consideration which you have to make. So if you're a serious customer who really needs that audit data, you have to ensure that you have enough space for that. Or if you're fine with purging it every 6 months or whatever the case might be, or you can move it to another server and store it there. So generally, if you have a production level cloud solution, you have auditing enabled, you would want to take your performance benchmark with auditing enabled. So if you don't want to put it into Ceilometer database, you can make the configuration so that it goes to the log. And you can also, if just to add to her, you can enable log rotation on your logs, or you can have RSys log server setup, and all that you can do. So there's that mechanism as well.
So Divya, for this audit enabling part, is it the same irrespective of public or private cloud?
Yes,
it's the same.
It's the same. So like I said, if you're using OpenStack as the cloud platform, it's the same. It doesn't change. And even if you're not using OpenStack, the PyCADF library, it's not an integrated part of OpenStack. It's just an open source library. You can always use it if you're using Python code, or else you can probably come up something similar for another language. So,
thanks.
So I have a question which is, so we are talking about security and auditing all these factors when we are using cloud for the maybe production or in any environment. And another important thing comes to the availability. For example, if we have a public cloud or a private cloud, multiple clients can use the same cloud in the configuration, whatever we are having there. So if there is any issue, then it can impact all the clients at the same time. So do we have any provision to take care of this availability factor as well here?
So I think you're mixing multiple things. The question, was it about high availability of your cloud?
Yeah, high availability, or you can say that if there is a downtime happens for the cloud machines, so all the clients will be unavailable at that period of time.
So the question here is actually slightly different from the audit topic that we're talking about.
It is completely different from the audit.
But otherwise, there is high availability that you can set up with OpenStack, wherein you can have multiple services run with high availability, which means that OpenStack is nothing but a bunch of services. You can have it run in a high availability mode. So one example is there is a concept called region in OpenStack context, where you can have 2 instances of OpenStack running with the same keystone in multiple regions in a HA mode. So one would be active and one would be passive, but both of them would be managing your same set of resources, which means that even if one of your cloud is down, the other can be brought up and the downtime will not be there.
Thank you.
Hi, I'm from the banking domain, and my area of interest in knowing this is that when you talk about auditing here, is the transactional data getting audited?
No, the transactional data is not getting audited. We're talking about auditing of the IaaS layer alone, which is the infrastructure as a service. And OpenStack here provides the infrastructure as a service layer. So we are not talking about, there will not be any data which is above that layer which will be audited or logged or anything. It's purely at the software layer.
Okay. And is there any mechanism to match the IaaS layer with the transactional audit?
As of now, it's not available, but then that would be the responsibility of the layer above it. So if you are using OpenStack, OpenStack provides audit mechanism and you are doing something on top of it, that would be something the layer
would have to be
above
built.
it. Yeah, it has to be built.
Thank you.
For the ignore request list, can you filter out at REST API level, or is it just at get post? I mean,
so what happens is here, by the time the request reaches here, I mean, you obviously know whether it's get or post or put. And there's a check which is made here which checks if it's get or post or whatever it is. If the ignore list has a get, which means that don't audit it, what happens is it doesn't audit, but it proceeds with the REST API.
no, my question was specifically get for a specific API. Is that ignorance is possible?
No,
that
level of granularity is not provided as of now.
Okay, thanks.
I guess there are no further questions. Thanks very much. It was a nice interactive session.
Thank you, Divya, for the insightful session and fielding all the questions very well. Thanks for the participation from the audience too. So I'm sure you all are aware about the Convene app, which you can download on your phones, and you can use that to rate all the sessions, give any comments as well. I'd like to request Divya to present a small memento to it. Sorry, I'd like to request Bharti to present a memento to Divya.